lost and down into the light now. Lost and down into the light now. Lost and down into the light now. Lost and down into the light.
Hello children, I believe that you have gone through the nomenclature, IUPAC nomenclature video very well and done the questions explained in the video as well as given in the assignment in your notebooks. So by now you are confident enough to name any simple organic compounds which come for you in the examinations. Moving on now to saturated hydrocarbons. Saturated hydrocarbons, we said, are those hydrocarbons in which the carbon bonds, the 4 carbon bonds, are all satisfied with single bonds. No double bonds or triple bonds are there. So let us move on to the alkane homologous series. Alkane homologous series. Remember homologous series, children? Homologous series means a family of compounds which have similar properties. Let us go on to, and they differ in the adjacent members differ by a CH2 group. Let us see the homologous series of alkanes. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane. This is the homologous series of alkanes. And which is the first member of the alkane series? Methane. Meth means 1 carbon atom. Okay. So you know the formula CH4, C2H6, and what is the general formula we follow here? CnH2n plus 2. You know that you have already studied in AP in mathematics, AP arithmetic progression. Yes, children? Yes. So CnH2n plus 2. So CH4, C2H6, C3H8, C4H10 and so on. Okay. We are seeing here that the corresponding the adjacent members differ by a CH2 group. That means they differ by 14 AMU mass. Correct? So as we go down the series, we see that the molecular mass of the compounds increases. And when the molecular masses increases, then what will happen to the physical properties? Physical properties will show a small gradation in the properties, like for example melting point or boiling point or density of these compounds. How will it vary down the group? The melting point or the boiling point or the density will increase as the molecular mass goes on increases. Yes, we already dealt about all that. Then we saw that the chemical properties will be similar. Physical properties show a slight variation, but then the chemical properties will be similar. And what else will be similar? The general formula surely is the same for all. The method of preparation will also be similar. Methods of preparation. And that only we are going to deal with now. The first 2 members of the alkane series, methane and ethane. Let us go to it and see how the similar methods of preparations for both. Methane, you know, is also called marsh gas. Why is it called marsh gas? Yes, Methane is called marsh gas because it is found, this methane is produced during the fermentation of cellulose in the marshy areas. Yes, dead parts of the plants. So it is, and you know another thing you must keep in mind here, that methane is a greenhouse gas, children. Greenhouse effect this methane causes. Okay, so methane. Let us go to methane's first method of preparation, and we will see how it is similar to that of ethane also. The first method of preparation is using sodium ethanoate or sodium acetate. Okay, sodium acetate plus soda lime. What is soda lime, children? Soda lime is an equimolar mixture of sodium hydroxide and calcium oxide. Okay, what it is? An equimolar, that is 1:1 ratio. Sodium hydroxide and calcium oxide. So sodium hydroxide we call what? Caustic soda. Yes, caustic soda and caustic soda, and this one we call what? Quicklime. Quicklime. So the soda lime word comes from what? Soda lime comes from soda from caustic soda and lime from quicklime. So soda lime. And what is soda lime? An equimolar mixture of 1:1. 1:1 ratio. Equimolar mixture of sodium hydroxide, caustic soda and quicklime. Okay. So when this sodium ethanoate or sodium acetate reacts with soda lime, in soda lime sodium hydroxide takes part in the reaction and calcium oxide does not take part in the reaction, but don't think that it is a drying agent, children. It is not a drying agent. It is used as it is not a catalyst because it is written on the arrow. Children generally take it as, they assume it as a catalyst, but no, here it is acting as a drying agent. Why it is acting as a, why do we need it so much here? Because we know that sodium hydroxide, caustic soda is highly deliquescent in nature. Highly deliquescent in nature means it will absorb the moisture from the atmosphere and start dissolving in it. So we don't want that to happen. We don't want it to absorb moisture, and that is why we keep a drying agent along with it, that is quicklime. So quicklime helps to keep sodium hydroxide dry. That is the function of quicklime here, and that is why we take not only sodium hydroxide as the reactant, but we take soda lime as the reactant. Okay, children? So just because it is written on top of the arrow, don't assume it to be a catalyst. When sodium ethanoate and quicklime are heated to a temperature of around 300 degrees Celsius, we see that we see Na2, COO, and one O is here, CO3 plus CH3 is left here, one H is left here, so it will become CH4. So what is formed? Sodium carbonate plus methane gas is formed, and this is the laboratory preparation of methane. Okay, and methane is collected by the downward displacement of water. This methane. Similarly, we can prepare even ethane with this same method. Okay, but instead of sodium ethanoate, there we will take sodium propanoate. Sodium propanoate plus soda lime heated to 300 degrees Celsius will give what? Again Na2COO. So Na2CO3 plus C2H5 plus 1H gives C2H6, again collected by the downward displacement of water. So aren't these both similar reactions, children? Similar methods of preparation? So all the members of the same homologous series will have similar methods of preparation. So this is one method of preparation we saw. Very important, the laboratory preparation of methane and ethane using sodium ethanoate and sodium propanoate. 300 degrees Celsius, and what is the function of quicklime here? Not as a catalyst but as a drying agent for keeping sodium hydroxide free from absorbing moisture. Okay. This is one method. Let us go on to another method, children. Method number 2. Method 2, we will see methyl iodide. Okay, methyl iodide or iodomethane we call it. Iodomethane. IUPAC name is what? Iodomethane plus nascent hydrogen, and 2 nascent hydrogens will be needed. Then what will we get? Out of the 2 nascent hydrogens, 1 hydrogen will react with this I and take it away. So it will become HI. Okay? And the other H will combine with CH3. Then it will become what? CH4. CH4. So one H has taken the place of I and becomes CH4. And the other H combines with I and takes HI separately. So this is another method. So iodomethane used for preparation of methane, and bromoethane. Bromoethane will be used for preparing ethane. Same, 2 nascent hydrogens. Then what? 1 nascent hydrogen will react with Br and make it HBr. And the other H will take bromine's place and become C2H6. That is methane. No, sorry, ethane. That is ethane. So similar methods of preparation, children. Iodomethane plus 2 nascent hydrogen will give methane plus HI, and bromoethane plus 2 nascent hydrogens will give C2H6 ethane plus hydrogen bromide. And from where will you get the nascent hydrogen? Nascent hydrogen means what, children? Nascent hydrogen means hydrogen in the atomic state. Hydrogen in the atomic state, and it is very, very reactive. Very, very reactive. From where do we get this? By the reaction between zinc powder and dilute hydrochloric acid. Yes? So this is about the preparation of methane and ethane. Now let us go to the properties of alkanes, that is methane and ethane. You don't have many properties in your syllabus, but one important property is combustion, that is complete combustion. Complete combustion, that is first one, let us say complete combustion. Combustion means what, children? Burning. Burning means oxygen will be required. So methane plus oxygen will give what? When oxygen is sufficient quantity. Oxygen is sufficient quantity, then what will be the reaction? And since this is a hydrocarbon, what will be the 2 products? Carbon dioxide and water vapor. Any hydrocarbon on combustion will give carbon dioxide and water vapor. So you will have And what will be C2H6 plus oxygen? Will again be carbon dioxide and water vapor. This is when sufficient oxygen is there, and when insufficient oxygen is there, then what will happen? They will give not carbon dioxide, but it will give carbon monoxide plus water. Water will be produced, but carbon monoxide will be formed. Okay, similarly, even ethane will give carbon monoxide and water. And still less, if it is even lesser amount of oxygen, very less oxygen, then you will see that it will give only carbon and water vapor. Carbon and water vapor with very less oxygen. So there are three cases: when there is sufficient oxygen, when there is insufficient oxygen, and when the oxygen is very less, and when the oxygen is very less. Okay, next property, and the very important property of alkanes is substitution reaction. What do you mean by substitution, children? In the place of something else. Substitution reaction, let us take. Substitution reaction. Alkanes, in the presence of diffuse sunlight, reacts with chlorine easily. Yes, or if not diffuse sunlight, then when you heat it to 600 Kelvin also, you will get the same product. That is, we will see the products. Methane plus chlorine will give, see, there are two Cls, right? When there are two Cls, one Cl will combine with one H from here, okay, and it will go as HCl, and three H's are left here, CH3, and one Cl from here will join. Okay, so if you are not understanding, let me explain this in the full structural formula. Okay, this is Cl2 and this is methane. So what will happen? One H will combine with one Cl and go away as HCl, and this Cl will come and take the place of hydrogen, and that is why we call it a substitution reaction, because chlorine is substituting hydrogen. Okay, so this is actually what is happening here. Let us now, is there any further chance of substitution? Yes, there is. Unless and until all the H's are over, there will be chance of substitution reaction. Now let us start with this one. CH3 we have in hand, CH3Cl, again plus Cl2. Then what will happen? One H will come out from here and combine with one Cl and form what? HCl. Then what will be left here? CH2, CH2. One Cl is already there and one more Cl will come. Okay, so it will become CH2, Cl2, HCl. Now do with this one, CH2, Cl2 plus Cl2. One H will come out, will form HCl, and in that H's place Cl will go, so it will form CH, Cl3. Then let us do with CHCl3 plus Cl2 will give this is chloromethane. With this is dichloromethane. This is trichloromethane. And this is tetrachloro. This trichloromethane is also called chloroform, children. Chloroform. Yes, chloroform. Remember earlier the doctors used to use this chloroform for anesthesia before surgeries. So that's same chloroform. CHCl3. These are the substitution reactions of methane, children. Methane had 4 hydrogen atoms in its formula. So there are 4 steps of substitution because one at a time one hydrogen is lost. So 4. Ethane's formula is C2H6. Ethane's formula is what? C2H6. So how many steps will be there for the substitution of ethane? 6 steps will be there. Okay, 6 steps, and you are going to write this substitution of ethane in your copy, okay, as homework, as assignment, which is already given in the assignment. So this one now you will copy down in your notebooks, and we will in assignment also you have to do of ethane. Now apart from this we have uses of methane and ethane. Uses, please go through the uses in the book. The main use, if you say, is that both ethane and methane are used as domestic fuel, is used as fuel, good fuel, because they give out a large amount of heat. Calorific value of these fuels are high. So that is all, children, in the alkanes part. Alkanes, the 2 laboratory methods of preparation we saw, one with sodium propanoate and sodium ethanoate plus soda lime, and the other one we saw with chloromethane and bromoethane with nascent hydrogen. So please learn all that, and only 2 chemical properties, also only 2 we have. Go through it nicely. The first one is complete combustion and the second one is substitution reaction, and you must remember very well that alkanes undergo substitution reaction. Alkanes undergo substitution reactions. Please register in your head, alkanes undergo substitution reactions. Okay, in your copy also, in nice bold letters, you write and keep alkanes undergo substitution reactions. That's all, children, for today.
Lost in the sound.